Human face recognition is one of the oldest image and signal processing fields. The application developed by Zsolt Husz and Lucian Prodan has as main purpose to automatically establish and/or verify the identity of a certain person using pictures taken by a video camera.
The system consists of a software package driving the camera and performing the necessary image processing. The system was designed to recognize human faces based on the following process. An individual sits in front of the camera, taking care to adjust the relative position according to the instruction displayed on the main window. When the software detects a good picture frame, meaning the proportion of the face features is correct, it freezes the image frame and launches the recognition process. The software detects a number of face features, such as the face dimensions, relative distances between the eyes, nose, mouth, and forehead, width of the nose. These features make up what we call the feature vector. All the feature vector's components are inside a standard feature dimension range, so the software can check if the current frame is an acceptable picture or not.
The application runs in two modes: database construction and identifying mode. Now let's see how can we introduce a new person in the database. The subject must sit in front of the camera until a good picture frame is captured. Then the searching process is frozen. The application detects the face properties used in identification process. We can observe that the identification isn't correct yet because the person isn't present in the database. We must introduce him. I create a new identity and then I add to this identity the captured image. Let's capture a new image. We can see that the software already recognized the person. For more accurate detections, meaning the software tolerates changes in how the same person looks, we must add other picture frames to the database. After capturing other frames, the introducing process is the same, except that we didn't have to create any new identities. In identification mode, the person who is to be identified has to sit in front of the camera and look straight into it. You can see that the program searches a well-detected face, indicating the moves that have to be made. The software searches for establishing the person's identity through continuously taking pictures. The process stops with the found identity being displayed on the screen.
Although the project was started from scratch, the results seem quite remarkable. With a non-expensive web camera, working with a low resolution of only 352 by 288 pixels, we obtained an approximate percentage greater than 80% in identification accuracy.
The face recognition software needs to be further optimized for proper implementation onto the Motorola DSP. Also, a high-speed data communication link will be needed to interface the video camera, the DSP and the host computer. Another improvement of the project will be the increase of the graphical resolution to minimize as much as possible the face features detection errors.